Good afternoon. Good afternoon. Am I audible? Yes, good afternoon. The use of NumPy and what is the use of Matplotlib library? Yes. So firstly, I am going to discuss with you about k-means clustering algorithm. So what do you mean by k-means algorithm? What do you mean by k-means? Yes, Dinesh Kumar, good afternoon everybody. So what do you mean by k-means clustering? So in case of machine learning, we have two different types of machine learning. One is called as a supervised machine learning problem and one more is called as an unsupervised machine learning problem. So in case of supervised machine learning, we have classification and regression problem. And in case of unsupervised machine learning, we have clustering and then association problem. So what do you mean by this clustering problem? So today I am going to discuss with you about k-means clustering. So what do you mean by this clustering? For example, what do you mean by unsupervised machine learning? So from the raw data points, unlabeled data points, the machine learning model, it finds the pattern hidden behind the raw data and it is going to come up with some important prediction result. What is going to happen in the future? So this is what is called as a clustering problem. So what do you mean by this k-means clustering? So the k denotes the number of clusters in the k-means clustering algorithm. So I have to iterate until it finds the optimal centroid. So I have to assume. So what do you mean by this k-means clustering algorithm? So it assumes the number of clusters are already known, called as a flat clustering algorithm. So the number of clusters identified in the algorithm, it is identified by the letter k. The k denotes the number of clusters in the k-means clustering algorithm. So the data points are assigned to a cluster in such a manner the sum of the squared distance between the data points and the cluster centroid should be minimum. So less variation within the clusters would lead to more similar data points within the same cluster. So this is the basic working principle of this k-means clustering algorithm. So cluster, so what do you mean by a cluster? For example, I have a mixture of different shapes, Aparna. So I have squares, circles, and then triangles. So I am going to group them into different clusters. Say for example, triangles, they are grouped into one cluster. Circles, they are grouped into one more cluster. And squares, they are grouped into the third cluster. Clear with this? So what do you mean by this cluster? So I am going to group the unlabeled data points. The raw data points are given as inputs to a machine learning model. From the raw data points, the machine learning model, it finds the pattern hidden behind the data. It is going to group them into different clusters. So that is the basic working principle of this clustering algorithm. So it contains some 4 steps. So all these are the different steps involved in the working of k-means clustering algorithm. So firstly, I need to specify the number of clusters. So the k denotes the number of clusters in the algorithm. So this is my first step. So the k value selection. So how I'm going to group the raw data points into different clusters. So firstly, I need to generate the k value. So based on that, I have to select randomly. I have to select some k data points and assign each data point to a cluster. So what do you say this? I'm going to classify the data based on the number of data points. And the third steps, I'm going to compute the cluster centroids. So all these are the different steps involved in the working of this k-means algorithm. So I'm going to compute the cluster centroid and then I have to iterate until I find the optimal centroid. So it is nothing but the assignment of data points to the clusters that are not changing anymore. So all these are the different steps that are involved in the working of this k-means algorithm. Clear with this? So firstly, I have to choose the number of clusters. The k value needs to be generated by this algorithm. So next, I am going to randomly select the k data points. And then I am going to assign each data point to a cluster. So I am going to classify the data based on the number of data points. And third step, I need to compute the cluster centroids. And finally, I have to iterate until I find the optimal centroid, which is the assignment of data point to the cluster that are not changing anymore. Clear with this? So I have to group. So what is the aim of any of these machine learning algorithms? So whether I can go for classification algorithms, regression algorithms, unsupervised machine learning model. So whatever type of machine learning models I'm going to do, so I have to minimize the error, the cost function or the error function, and I have to maximize the accuracy. So that is the aim of all these kind of machine learning models. So next I'm going to discuss with you about the working of k-means algorithm. So firstly, the sum of the squared distance. So what are the different steps involved in the working of k-means algorithm? So the sum of the squared distance between the data points and the centroids should be computed. And I have to assign each data point to the cluster that is closer than the other cluster, centroid. So finally, I have to compute the centroids for the clusters by taking the average of all the data points of the cluster. Clear with this? So what are all the different steps? So how does this k-means algorithm? So all these are the different steps involved in the working of this k-means algorithm. So I have to choose the optimal value of k. So what are the different steps? The sum of the squared distance between the data points and the centroids should be computed. So after doing this, I have to assign each data point to the cluster that is closer than the other cluster, that is centroid. And finally, I have to compute the centroids for the clusters by taking the average of all the data points of the cluster. So it follows the expectation maximization approach to solve the problem. So what is the use of expectation and maximization? So expectation step is used for assigning the data points to the closest cluster. And maximization step is used for computing the centroid of each and every cluster. So the entire k-means algorithm, it is based on the expectation maximization approach. Clear with this? So what do you mean by this k-means algorithm? So basically I just gave you a brief introduction to k-means algorithm. Next I am going to proceed with the implementation. So how the customer segmentation, this is being performed by using this k-means clustering algorithm. So I am going to discuss with you about the implementation of this algorithm. So you can see here. So the data sets are collected from various sources. So the system architecture looks like this. So the data sets are collected from various sources and then it is given to the pre-processing module. So all these are the different blocks involved in this k-means clustering algorithm. It is given to the pre-processing module. So I can go for different types of pre-processing. I can go for scaling, encoding. So I can go for different types of pre-processing and then I am going for this k-means clustering algorithm. So next it is given to the k-means clustering algorithm. The features are extracted, it is given to the clustering algorithm and finally I am calculating the accuracy score here. So what we are going to do in this project, so we are going to collect the customer data sets from various sources and they are being grouped into different clusters. So that is the basic working principle of this k-means clustering algorithm. So what are the different hardware and software requirements that are essential to do this project? I require Windows 7, 8 or 10 64-bit operating system and 4 GB RAM memory capacity. And what are the different software requirements? I require the data set. So Python 2.7. So everything is performed using Python 2.7, Anaconda Navigator and libraries. So all these are the different hardware and software requirements that are essential to do this project. So firstly, I need to import the corresponding library. So what are the essential libraries? So firstly, I need to import the corresponding library. If I want to use NumPy library or if I want to use Pandas library, Matplotlib, Seaborn. So firstly, I need to import the corresponding library. So what are the essential libraries? So firstly, I need to import the corresponding library. So after importing the corresponding library, using the alias name using dot operator, there is an inbuilt function called read CSV function. Whichever inbuilt functions I have to call, using the alias name using dot operator, I have to call the corresponding inbuilt function. So I am just calling this function called read CSV function. So within double quotes, I am just reading the CSV file, mallcustomers.csv. It is stored in the variable df. Using the variable name using dot operator, I am just calling this info function, information. It just provides an information about my data frame. So totally it contains some 200 entries. So what are the data types of different columns? Integer data types, object data types. And totally it consumes some 7.9 plus kilobytes of memory. And df dot column. So what are the different columns that are present in my data frame? So I can go for customer ID, gender, age, annual income, spending score. So all these are the different columns that are present in my data frame. And df dot head function, it prints the first 5 rows of my data frame. Say for example, I have customer ID, gender, age, annual income. So it just prints the first 5 rows of my data frame. And if I want to drop the customer ID along column axis, so axis equal to 1 and in place equal to true. So next comes the EDA part, visual analysis, exploratory data analysis. So using the matplotlib alias using dot operator, I am just creating a figure window. So whichever inbuilt functionalities of matplotlib I want to use, using the alias name using dot operator, I am just creating a figure window. And there is a parameter called figure size. I am mentioning the figure size as 10,6 figure window. And PLT dot title. So I am giving the title as ages, frequency, and axis style. I am giving here as dark style. And whatever is the type of plot. Say for example, using the alias name SNS dot, I am just calling this violin plot. So y equal to df of age. So I am just showing in the form of a violin plot. So using the alias name, using dot operator, I am just creating a figure window. So whichever inbuilt functionalities of matplotlib I want to use, using the alias name, using dot operator, I am just creating a figure window. So whatever is the figure size, there is a parameter called figure size. So I am mentioning the figure size as 15,6 figure window. And PLT dot subplot. So I am just creating this subplot, and all these are the different parameters. So one row, two columns, and the position where I have to place my subplot. And using this alias name, so I am just creating a box plot for spending score. So what is the minimum value, maximum value, and there is a middle line in between. It is called as the median line. So you can see here at the second position, I am placing the annual income. So all this comes under visual analysis. So I am just visualizing my data in the form of various types of visualization plots here. And df dot gender dot value counts. Say for example, how many male patients are there, how many female patients are there. So value counts. So you can see here. So using Seaborn alias, it is represented in the form of a bar plot. So title I am giving has number of customer and ages, and explainable age, and then number of customers. So score you can see here. So spending score and number of customers having this type of scores 1 to 20, 21 to 40. So how I'm going to group the customers into different segments. So based on all these parameters. And income, so based on the income level, so how many customers fall in the corresponding income level. So from MPL toolkits, I am just importing Access 3D, and I am getting the style, fixing the style as white grid, and access.scatter function. So you can see here. So plt.x label I am giving as age, and y label I am giving here as annual income. So projection equal to, so within single quotes I am giving here as 3D projection. So I am just showing in the form of a scatter plot. So X label I am giving here as age, Y label I am giving here as annual income, and Z label I am giving here as spending score. So from sklearn.cluster I am importing k-means algorithm, and within cluster sum of squares I am just initializing an empty array for k in range of 1, 11. So I am just initializing this k-means algorithm and number of clusters. So equal to k, and init equal to k-means plus plus. So k-means dot fit function. So I am just training the model, and then I am appending this. So inertia, it is appended to the within cluster sum of squares. So from this you can see after 5 the k value is flattening, so k value will be 5. So this is called as the elbow method. So I am just estimating my k value. Finally, I am just initializing this k-means clustering algorithm. So whatever is the type of algorithm, I am just initializing this k-means algorithm. And within simple brackets, I am just giving number of clusters equal to 5. It is stored in the variable km. And using this variable name, using dot operator, I am just calling this fit predict function. So from this ILOG, colon denotes all rows and first column onwards. It is stored in the variable clusters. So clusters, it is stored in the variable df of label. From MPL toolkits.mplot3d, so I am just importing this axis 3D. And using this alias name, I am just creating a figure window. So whatever is the figure size, I am giving here as 20, 10. So fig.add subplot. So I'm just adding a subplot. Whatever is the row dimension, column dimension, and the position where I have to place my subplot. And projection equal to 3D projection. So from this age, I'm just picking. So label equal to 0, annual income. So spending score. So it is indicated by different colors. I'm just showing in the form of a scatter plot. And plt.x label I am giving here as age and y label I am giving here as annual income. Clear with this? So based on age, how I am grouping the customers, you can see different colors. You can see based on the annual income and based on the spending score. So it has been grouped into 5 different clusters. They are indicated by different colors. With this, I am just stopping today. If you have any doubts, you can just ask me. Any doubts in today's topic, whatever I discussed, everything is clear.